Hello, dear students. Assalamu alaikum. This is Dr. S.M. Abdul Razzaq, Associate Professor, Department of Physics, Shahjatpur Government College, Shahjatpur, Shirazganj, Bangladesh. This is my YouTube channel. My channel's name is GJG. Please subscribe to my channel to get the next lecture. Today, I am going to teach you the most fundamental law of electricity from current electricity chapter. This is Ohm's law. Let's get started. Ohm's law. German mathematician and physicist Georg Simon Ohm developed this law in 1827. Ohm's law states that the potential difference or voltage difference across a conductor is directly proportional to the current flowing through it, provided all physical conditions of a material and its temperature remain constant. This law establishes the relationship between voltage, current, and resistance of a conductor. Let us now discuss mathematical form of Ohm's law. Suppose a current I is flowing through a conductor AB having resistance R from point A to point B. A is higher potential point, B is lower potential point. Plus sign indicates higher potential point, minus sign indicates lower potential point. Let potential at point A is BA, potential at point B is BB. Since A is higher potential point, B is lower potential point, then BA is greater than BB. So the potential difference between the point A and B will be BA minus BB. According to Ohm's law, BA minus BB is proportional to I, or BA minus BB is equal to IR. Here, R is proportionality constant. It is called resistance of the conductor AB. Now, BA minus BB is replaced by B. Therefore, B is equal to IR. And this is the mathematical form of Ohm's law. If BA is equal to BB, then product of I and R is equal to 0. Since R cannot be 0, therefore I must be 0. Therefore, we can say that no potential difference, no current. It is also noted that current always flows from higher potential point to the lower potential point in the electric circuit. B is measured in volt, I is measured in ampere, R is measured in ohm. Ohm's law is represented by a triangle. Let us now first draw a triangle and divide it into three sections. This is section 1, section 2, section 3. To calculate B, we cross it out from this figure. What we see now? We see that I is multiplied by R. Therefore, the value of B is equal to IR. To calculate I, we cross it out from this figure. What we see now? We see that B over R. Therefore, the value of current I is equal to B over R. To calculate R, we cross it out from this figure. What do we see now? We see B over I. That means B is divided by I. Therefore, the value of the resistance R is equal to B over I. Three mathematical form of Ohm's law are B is equal to IR, or I is equal to B over R, or R is equal to B over I. Let us now study the graph of Ohm's law. First look at the table. The first column represents voltage, second column represents current, third column represents resistance. We have chosen some arbitrary voltage here: 1.5 volt, 3 volt, 6 volt, 12 volt. For 1.5 volt, the current is 0.5 ampere. For 3 volt, current is 1 ampere. For 6 volt, current is 2 ampere. For 12 volt, current is 4 ampere. Look at very carefully. When voltage has been doubled, the current has also been doubled. The 1 ampere is 2 times of 0.5 ampere. 2 ampere is the double of 1 ampere. 4 ampere is double of 2 ampere. But for all cases, the resistance of the material is same, and it is 3 ohm. During Ohm's law experiment, temperature remain constant. Therefore, resistance remain constant. Mathematical form of Ohm's law, V is equal to IR, is similar to Y equal to mx. And Y equal to mx is the equation of a straight line that pass through the origin. Therefore, graph of the V is equal to IR is the straight line passing through the origin point. Slope of the straight line is equal to R. Now, if we put current along x-axis and voltage along y-axis, we will get a straight line like this. And slope of this straight line represents the resistance of the material, and that is 3 ohm.